Hi everyone, my name is Thomas Kim. Today is January 16th, 2024. It is 1 past 12 a.m. in the midnight. I have two YouTube channels. IQ95, the Homo Dawkins. This is my Korean channel. In my Korean channel, I have 835 videos. If you click this link, you can visit my English channel, IQ95, the Homo Siliconians. In this channel, I have over 1,300 videos. If you scroll down, you can find linear algebra and threading building blocks. In this playlist, I have 67 videos. If you click this link, you can watch my previous videos in the linear algebra and threading building block series. In this playlist, I filmed 67 videos. Approximately 4 years ago, I filmed videos in this playlist. If you scroll down, the last episode, 67. While filming videos in this playlist, I expressed my idea that someday I will implement matrices of functions. After 4 or 5 years later, I finally implemented matrices of functions. Click Show More. You can find download source code episode 67. If you click this link, you can download the source code. You can unzip it, rename it 68, copy the folder, paste it in your working directory. Now, open up Visual Studio Code. Select Geometry Tensor Calculus. From folder 68, you can find test build clang.cmd. In this file, we will find and replace C++17 with C++20. Replace all. We will also find LTBB with LTBB12. Replace all. Open up dp-cpp. We will find dp-cpp and replace icx-cl. Replace all. We will also replace cpp17 with cpp20. Replace all. Now open up test build gnu.cmd. We will replace C++17 with C++20. Also LTBB with LTBB12. Replace. It should be LTBB malloc. I made a mistake. It should be LTBB malloc. Also, in the clang, it should be LTBB malloc. Open up, build MSBC CMD. We will replace C++17 with C++20. Then open up your command prompt. cd 68 complex matrix and constraints dir.cmd. What's the problem? Okay, this is a folder. I made mistake. Close all. I will close Visual Studio Code. In this folder, copy, paste it here. Remove this folder. We have to close command prompt. Remove this folder. Rename it 68. Open up Visual Studio Code again. Geometry Tensor Calculus. Now open Talk Play Fun matrix2d.hpp. Ctrl B. In this file, find self parentheses cancel group execution. Now this part of code should be fixed. Auto c.tbb task current context. This CT is pointer. CT cancel group execution. We have to disable TBB task self cancel group execution. Then we have to fix our code like this. Open up your command prompt cd 68 complex matrix and constraints.cmd test build clang. Now all our previous source code built successfully. If you look up this folder, you can find the complete source code. For example, Gauss-Jordan elimination, complete pivoting, LU decomposition, scaled pivoting, triangularization. I provide all the source code for the linear algebra and the threading building block series. You can watch these videos in this playlist and try the complete source code in this folder. I will upload this folder on my file server and put a download link below my current video. From my English channel, if you click this link, you can visit my Korean channel. If you scroll down, you can find differential geometry and tensor calculus. Click this link. In this playlist, if you scroll down, 041, matrix 31, solve EQN, Jacobian, vector. Show more, scroll down, download current video source code. Show in folder, unzip it. Rename 042. Copy the folder. Paste it in your working directory. This is folder 042, Green Theorem. In the Visual Studio Code again. Now, I will close these files. From folder 42, click this button, rplc-prms.cpp. Hit enter. Ctrl B. I will copy and paste these links. Also, this link. This is episode 41, matrix 31. In my Korean channel, I explained how to use solve eqn, how to evaluate Jacobian matrix. Here include cpg, matrix.hpp. Just so you know, right filming this video, I updated C++ library extensions. If you want to try my source code on your machine, you need to download up-to-date CPP extensions dated 2024 January 15th. Namespace, CPT, CPG, types. Namespace, CNA, CPG, numerical analysis. Namespace, CNM, CPG, numerical analysis. Math. CPT stands for CPG types. CNA stands for CPG numerical analysis. CNM stands for CPG numerical analysis. Math. I will use these namespace alias CPT, CNA, CNM all the time. So you have to make yourself familiar with these namespace alias. I would also declare using namespace CPG numerical analysis commands using namespace CPG numerical analysis operators. Please be advised, using namespace declaration in the global scope is bad idea. I don't recommend using namespace declaration in the global scope. However, for my video sessions, I will be using only my own C++ source code. So for convenience, I will use using namespace declaration in the global scope. Void solver eigenvalues int main, copy this function name and paste it in the function main. CPG display function name. I will give you my warnings once again. Warnings. I clearly state my warnings here again. I will be using unconstrainedly, profusely, pretty and fancy names in my source code. These are declared in the namespace. So if you using namespace declarations in the global scope, as in this sample video, you cannot escape from name conflicts with pretty and fancy names. You cannot avoid name clashes. I explicitly stated my warnings. If you want my source code, confine using namespace declaration in the local scope instead of in the global scope, like this. However, for convenience sake, I'll be using namespace declaration in the global scope just for convenience purpose. I will copy and paste these links. If you control-click, you can find eigenvalues and eigenvectors. This Wikipedia page. If you scroll down, you can read the theory. Three-dimensional matrix example. We will try this example. I arrange it side by side like this. I made a simple but serious typo here. It should be operators, also operators. Now we will define matrix A like this. Although A, C, and A create static matrix. This is 3 by 3 matrix. Open parentheses. 2, 0, 0. 2, 0, 0. 0, 3, 4. 0, 3, 4. 0, 4, 9. 0, 4, 9. We defined matrix A like this. We are creating a static matrix, 3 by 3 matrix. Now, in this expression, we need to declare 3 by 3 unit matrix I. Instead, although TI, CNA create diagonal matrix 3. 3 means 3 by 3 square matrix with diagonal elements. T. This T is special. Although T variable. Ti represent lambda I. Then, although A, T, I equals, we subtract lambda I from matrix A. Subtract Ti from matrix A. So ATI represent this matrix. Now we take determinant. Although P ATI determinant, this P represent this polynomial. P is called characteristic polynomial. Now we have to solve determinant a minus lambda I. So we have to find the values of lambda in this characteristic polynomial. How? We can use Newton method or eigenvalues. CNA Newton method. This is function. We provide this characteristic equation P. Then we provide the range over lambda in this characteristic equation. This is guess or estimation. I assume the range of lambda lies between negative 20.0, positive 20.0, semicolon. I will delete the blank space, then give a carriage return. If eigenvalues empty, we failed. Qstd, cout, failed. cpg, and there. If we failed, there is nothing much we can do about. We simply return. Otherwise, Qstd, cout, eigenvalues, cpg, and there. Now we will build cpp clang ++. We use C++20 standard. Not in this folder. dir cd 042 green theorem. In this folder, you can find rplc-prms.cpp, clang std c++20, rplc-prms.cpp, ltbb12 or c.exe, hit enter. I will copy this command string, copy, Control Home, paste it here. Now clc. I got two values for eigenvalues because we have third order polynomial. I expect one more value for lambda. In such case, scroll down. I want to split this range to smaller chunks, such as 20 segments. This 20 means I want to split this range, the range for lambda, to 20 subsegments. Then apply Newton method for each subsegments. With this, we recompile clc. Now I got 1 to 11, 3 eigenvalues, as in this document. In future sessions, I will explain how to evaluate eigenvectors too. We will build using GNU G++ compiler. clsg GNU compiler also works. Now with the Microsoft compiler. dir cd 042 green theorem cpp cl std c++20 don't miss EHsc rplc-prms.cpp fe:/m.exe hit enter cls m. Microsoft compiler also works. I will copy this command string, Control Home, paste it here. Now we will try with CUDA compiler, nvcc, std, c++20, rplc, prms.cpp or n.exe, hit enter. cls n. CUDA nvcc compiler also works. Copy this command string, paste it here. Now Intel compiler, dir cd 042 green theorem icx-cl Qstd c++20 EHsc fno-sycl rplc-prms.cpp or i.exe, hit enter. cls I. Intel compiler also works. Copy this command string, paste it here. In case of GNU compiler, you can use G++ like this. On Windows platform, clang, G++, CL, nvcc, icx-cl, all 5 compilers work successfully. I will upload folder 42 green theorem, folder 68 complex matrix and constraints. I would highly recommend you to watch videos in the linear algebra and threading building blocks in this playlist. I will upload fixed code, folder 68 complex matrix and constraints. Then you can watch these videos that I filmed 4 years ago and learn advanced algorithms in linear algebra.